And this new, and again, welcome to Algebra 2 Honors and to 115 where right never ends. Thank you. So Lily she just said so fast.
Because I hear it every day, I just might as well be.
Yeah, so that's good. I like that.
We didn't get problem 20 yesterday.
Oh, we didn't?
We did. We turned it in.
No, we didn't.
We turned it in.
Yeah. Oh, I never turned it in.
Well, he said he could turn it in today or yesterday.
Yeah, so you can turn it in today. That's
I
fine.
never actually finished number 20.
I didn't get number 20 either.
Yeah, we did. So we finished number 20 just at the end. So
I don't have mine done.
so turn that in today or tomorrow. So just turn it in before I grade, okay? But what we're doing
Just get a 90.
is we're advancing into chapter 6 in our book, which has to do with graphing cubic functions. So what we're going to do is
So we're taking notes today?
essential question. Well, you don't need to take notes on this. It'll be very fast.
Oh, so just.
And we're going to do some exercises on this very quickly, so I won't worry too much about it. But essential question, how are the graphs of f of x equals a times quantity x minus h cubed plus k related to the graph of f of x equals x cubed? So basically this whole formula here is similar to the ones we did for absolute value functions and quadratic functions, but we're applying these here, the same principles of transformation to a cubic function. So you're going to see a lot of the same patterns of what other types of transformations we did. You remember what they are? They are what? We talked about, and I know that was last year.
What? What? I wasn't in your class last year.
Yes, you were.
No, I wasn't.
Oh, 2021.
Oh my.
Right? Not last school year, but last calendar year, right?
Come on, Mr. James.
So that's what I meant. Okay, last calendar year. Thank you. So, what are the types of transformations we talked about? Remember what they were? Who said translation? Very good. Good work. So one of the things is a translation.
Did we talk about reflection?
Yeah, we did. So translation is going to be taken care of by this H and this K. Okay, who said reflection? So Lily also. Say reflection, right? What's going to take care of reflection here? How does reflection happen?
Across the y-axis.
Well, actually, the type of reflection we talked about more often than that, Matt, we talked about reflection about the x-axis.
Well.
No, there was a reflection about the y-axis, so you're not wrong in what you said. But what it is, if A is what? Less than 0, then we reflect about x-axis, right? And what else? There's one other thing we talked about that is taken care of by A. What does A also do?
Slope or width, narrow.
Yeah. So she said. So this is really good. She said slope, and then she kind of self-corrected to width and narrowness, right?
Yeah.
So the width and narrowness is what this has to do, and we call this. So A also controls. We'll just say controls vertical stretch or compression. And that's what you meant, Jay, is that right?
Correct.
And correctly she says it affects the width or narrowness of the graph. So those are the types of transformations we're going to be talking about here, okay? Which we have done, and I said Lily picked up on last year, which means last semester.
Right.
Right? Working that over. So I kind of threw her off a little bit. And then we talked about this during 6th period. You see that acronym TEKS? You know what that means?
Teach. That's what you have to teach us, right?
Yes. And what do those 4 letters stand for?
Education. K.
Kick.
Okay, what this stands for is Texas Essential Knowledge and Skills. That's what that stands for. And so the Texas Education Agency puts out these things that we are supposed to learn advancing through our mathematical career. So that's why. So a lot of times if you ask why are we doing what we're doing, it's because the state tells us what we should do. Is that a wise thing to do?
No. Yes.
Why or why not?
Yes, of course.
Because why would we listen to the state?
Well, what it is that Madeline is doing something is because one thing we as Americans do, and we have a history since the founding of the country of questioning things, right? We question our government, we hold our government responsible. Yeah, they make us come to school.
That why.
So to me, it's sort of an American defiance, and so that's the same reason that people decide they don't want to do a certain thing, because we don't want the government telling us what to do, right?
Right.
All the time. But still, we put up with some things like wearing seat belts because people agree that the law requires us to do it, right?
I don't wear a seatbelt.
Yeah.
But it restrains our freedom, doesn't it?
Right.
Somewhat. And so there's sort of a balance, and the government tries to figure it out, and we who elect a government try to figure it out. But what happens is, Lily makes a good point, because what happens is they're trying to prepare each one of us to be qualified and educated. Why is the government concerned about our level of education?
Because they hate us.
Because they hate you?
Yeah.
So we can be smart.
So you can be smarter? Why does the state care about us being smarter?
So we get good jobs.
Good jobs, productive opportunities, and also with the better education, can that help the economy of the state eventually?
Yeah.
Yeah, it can.
Because the next generation will be really smart.
Next generation and all that. Yeah, so we can think, if you think about it a little bit, you can see why they would want us to have a certain standard of learning. So that's what this is about. Okay, those are some good things, and even Madeline, even your comments about independence of the state, that's good too. Okay, so the first thing we're going to look at today, and we're going to do, Sierra, some work on this first, is we have graphing and analyzing f of x equals x cubed. And so this is what's called a basic parent function. F of x equals x cubed. And if you plug into this function -2, you get an output of -8. If you plug in -1, -1 cubed is -1, and 0 cubed is 0, and 1 cubed is 1, and 2 cubed is 8. And so you can go ahead and plot this like this on your coordinate plane, and it goes something like this. So quite a steep curve, isn't it? I want to get like this, yeah. So something like this. I'm trying to get it. I'm going to show you why I'm trying to get close to right. Okay, is that about what it looks like? Yeah, that's about what it looks like. So we're going to examine some features of that. So what is our domain of this function here? And actually, we're not going to fill in. What is our domain of this? Domain's going to be all real numbers. Okay, greater than -infinity, less than infinity.
So you just put that little double R thing instead.
You could, yeah. And what it is, if you look at it, Madeline, the textbook actually did that. That's a little script R right there. Very good. So you're paying attention. Good job.
Thank you.
So our range is going to be what? Same. Same, right? Greater infinity, greater than infinity, less than infinity. The end behavior, as x approaches infinity, f of x approaches
Negative infinity.
fx approaches infinity.
Wait, as x approaches infinity?
F of x approaches infinity.
Okay.
As x gets bigger, y gets bigger, right? And as x approaches negative infinity, f of x approaches
Negative infinity.
negative infinity. And then it says, what are the zeros of the function? Well, there's x equals 0, that's right. And then the next row says where the function has positive values, where x is greater than 0. Where does the function have negative values? Well, where x is less than 0. Okay, and then where's the function increasing?
On 0?
Yeah, but where else? All real numbers. The function is increasing all real numbers. Always increasing. So I'm going to put always increasing, right? And you can say it a bunch of different ways. So always increasing. And then we have the function never decreases. And then it says, it gives this thing, if the function, is the function even or odd
It's even.
or neither?
Is it even?
The function is odd,
What?
and odd because x cubed, well, I don't like the way they word it. I'm going to word it differently on the next thing. Actually, so because negative x cubed is equal to negative f of x, or f of equals negative x cubed. That's why. We're going to talk about that a little bit later. So I'm going to hand out some sheets for us to start working on today. And I don't know how far we're going to get because of, we're going to be dismissed a little bit early today, but that's all right.
Are you just gonna do yours now?
Carly, I'm just gonna do it later. It's not even due till tomorrow. No, it's not even due tomorrow, is it? I got Monday.
How is everybody doing today?
I got Monday.
Tired.
Tired?
Pretty stressed
Terrible.
out.
Honestly,
You're stressed
honestly,
out?
Terrible.
Stressed.
I'm not stressed at all. I'm just terrible.
Do you have his number? Yeah, I have his number. It's not this one.
When,
Buenas noches.
okay,
Buenos dias.
Emily's still hanging out, but what happens is, a long time ago I was working, and it was a time when Princess Diana got married. Well, I don't want to go into
You got married yesterday?
it. Princess Diana.
What is that? I don't know. Yeah,
That's a long time ago. That's ancient history.
Charlie, what are you giving him?
But I was over watching TV at one of my co-workers' place who was Canadian, and since he was a subject of the British throne, thanks. Since he's a subject of the British throne, he was all enthralled by it, and I just thought it was awful that they had a royalty in Britain. Not awful, but it was like, hey, that's not important.
Yeah.
We're American. We don't have kings and queens.
Yeah.
We do have presidents, but they are temporary, right? They're not a permanent fixture.
Except for Donald Trump. He's permanent. Hey.
All the presidents serve at the request of the public for a limited period of time. Okay. So, right now, what we have is, I want you to look at number 1 and just work through that, help each other, and we'll go over it. What we did in 6th period is that people were able to get most of it. And so help your neighbor, working through number 1, and we'll go over it in 5 minutes. How's that? Can you do that?
I can try.
Yeah, try, do your best. I don't think I had anybody in sixth period who got all of them, but like most of them.
So you said we're
In
gonna
5
do them
minutes.
individually and then like.
Yeah, then we'll go over all of them. So see how many you can get. They're very similar to the ones we just went over. Right?
Which paper is it? I didn't get one.
You didn't get one?
Is this one?
Here, this is yours.
You forgot Ashton. I forgot he sits up there.
Yeah, we got it. Yeah, that's okay. He was good about it.
It's not okay.
He was nice about it.
You messed up.
Good. It's easy to forget. I forget too.
I can't see papers on crap.
Okay, the one from Monday, I wasn't here.
I need
He
drugs.
said I had 0 because he was on Monday.
Guess what? I didn't even know you tested it.
Do you really?
I did. Now, I'm sad to say he's not mine.
Are you serious?
You're not? Yeah.
It didn't look at me.
He's not mine. He's not mine.
See that cake? I was
And I'm just saying.
My
Jeff was like all right
And
there, you know?
I turned it in yesterday.
Well, you know, I think you remember Tyler?
Oh, you know what?
Oh my gosh, that's
Professor?
okay looking.
Go.
It didn't.
He was okay. I mean, that was really good.
You guys ever go to Camp
Do you have your paper?
Take it.
Yeah, I'm doing something for her really fast.
Camp Cody, yes.
Yes, Camp Cody, we were at Camp.
Where it was,
She's not
where
done.
it was
Yeah.
Like, I'm about to be done.
the guy, what's his name, Travis Bader?
Yeah.
Oh, he was hot too.
Oh, you smell
Yeah.
it.
Yeah, he was.
I have a picture of him in my
How are you
phone.
doing?
I'm gonna try to see it. And I'm like, just imagine if you laughing.
I like the discussion about passwords and stuff like that.
Like,
I need a pantry.
Why do you do
Jeremy got
I'd be confused with title. Obviously because.
pastor for the.
See,
Does he
that's
do
all.
camp?
Yeah. He just
That's
gets
it.
it. He
Injury
said
off.
he was in a story the other day. And he was leaving. And it was his last night. So
That's
he
not-
oh shit. And I mean, like he was leaving for that. I didn't know he was.
Yeah, I think it's
Pardon this interruption, teacher. I need the drum line
Brownies and vanilla.
members to head to the band hall, and I need all the cheerleaders to the cafeteria.
Oh, cheerleaders!
2:30, I have pink eye.
Blueberry tart.
Wait, what for?
Our send-off.
Bye, Mr. G.
The prankster, good.
Yeah.
The pranksters, yes.
Like what we did on Monday. Hallway.
Oh, yeah.
Also, look, Wago.
I like it.
Actually, that guy's score check.
Hey, Charlie's a cheerleader, Mr. G.
I'm in the male squad.
Yeah. I'm on the male squad, Mr.
Very ready.
I actually won.
Hi, sweetie. How have you been? You talked to me about school ago. Sorry. How are you? You said I'm good. I'm better now that I heard from you.
And then he didn't but then he saw you
I would rather
with
be my
Christmas.
I'm pretty sure this calculator.
Didn't even like, honestly.
I mean,
No, I think it'd be wrong with that somebody. That's the thing. Everybody's trying to live. Right here.
going better.
That's supposed to be right there.
I'm doing the new color.
You go to that?
Should be X.
Actually, I'm doing it to you. You got it. Oh God, you got it, bro.
Yeah, so this is supposed to be X cubed up here, guys, right here. See that? Ashton asked me about this top line. F of X equals X cubed. That's what that is. You see that? Right? Yes? Okay, let's let's go over
How
this.
am I supposed to?
I know.
Put up in the street now.
Okay, so this one here says, did anybody get most of these done?
No, not really.
Let's go over we're kind of up against a little bit of a time crunch. So let's go over this pretty quickly here. So it says graph. So if we have x f of x,
I'll drive.
and we put in -2, -1, 0, 1, 2, we get outputs of -8, -1, 0, 1, 8.
Why'd you start at -2?
Well, I'll answer that question after I finish graphing it. Then I'll answer it to you. So if I put in -2, -8, go right here. -1, -1 here. 0, 0 here. 1, 1, and 2, 8.
Mr. G, what? Okay. Never.
And so we go ahead and graph like this.
But I can never graph like that.
Like, how did you get that?
That's a -8, -1, 0, 1.
I don't understand how you got that. Cube.
Oh, really?
Yeah, really?
Well,
So is it just the same thing every time?
what it is, I'll show you what it is. Like if you put this in your calculator here, right? And you go to your table view, you're going to see -8, -1, 0, 1, and 8, right?
Right.
Yeah, just a minute. Okay. So Kimberly asked a very good question. I'm going to answer it. That was really good. Thank you, Kimberly. She asked, why did I choose these numbers here? Well, if we put in -3 or +3, what would we get as an output? 27,
So you're
right?
just using random numbers?
Okay, let me listen again. So Carly is asking a similar question to what Kimberly had. Let me try to answer it again. Okay, listen carefully. If I use -3 and +3, what will we get as an output?
0.
No. What's 3 cubed? 27. Right? Is the dimension of the graph here up to 27?
No.
No, it's not. So accordingly, it doesn't make any sense to use any numbers outside of this span from -2 to 2. You see why, Kimberly? See why?
Yeah.
So that's why, just according to what's available on the grid, those are the integers that make sense. All right? So that's why. Carly, did that answer your question? Kind of, okay. So now it says, what is the function's domain and range? So what's our domain here? What's our domain or possible x values for this function?
All real numbers.
All real numbers, right?
Uh-huh.
And what is the range going to be? Also all real numbers. So I'm going to put domain/range. It's going to be all real numbers. So we're going to write that as -infinity, comma infinity, right? And then what is the function's end behavior? Okay, as x approaches infinity, what does f of x approach?
Infinity.
F of x approaches infinity. I want to thank Madeline and Ashton. Good job. Okay, and then as x approaches -infinity,
F of x approaches -infinity.
f of x approaches -infinity. F of x approaches -infinity. All right, good. And what are the graph's x and y intercepts? What's our x-intercept
The
here?
x-intercept is 0 and
X-intercept is the coordinate pair 0, 0.
and it's the same thing for y.
Same thing for y-intercept. We have 0, 0.
Correct.
Identify the intervals where the function has positive values. So we'll say f of x is greater than 0, where what? Where x is
0. 1.
No.
I'm
f of x is greater than 0 where x is,
Infinity.
where x is greater than 0.
I said 0.
0 is not right, greater than 0.
Greater than 0.
Right. So basically it's saying, it's really almost related to what our end behavior is. And so identify intervals where the function, I said negative values. So f of x also is less than 0 where x is less than 0. And then it says identify intervals where function is increasing. So f of x is increasing where? Where is f of x?
It's on infinity everywhere.
Yeah, everywhere. You say infinity.
Hello, I need Michelle to come sign out, please.
Okay, she'll be headed your way.
Thank you.
We'll just say everywhere. And then it says, tell whether the function, where's it decreasing? Where's f of x decreasing? Since f of x is increasing everywhere, f of x is decreasing where?
Nowhere.
Nowhere. So it's kind of a logical thing, right? The moment we know that f of x is increasing everywhere, we know it's decreasing nowhere.
It's in the paper chemistry.
Okay, thanks. This says, tell whether the function is even, odd, or neither. Explain. Is this function even, odd, or neither?
It's odd,
It's odd. Why do you know it's odd?
because that's what it was earlier.
Okay, so she remembered from that. Very good. She's paying attention. Good job. Do you remember, and the cheerleaders aren't here now, they're going to do celebrations. Remember we had this thing?
Odd,
Odd.
even.
Even. Hey, you guys are awesome for remembering that. Good job. Lily, Madeline, excellent. We've really had some good things. So odd, I agree 100%. No, and others too, but you,
Me too.
you maybe especially. Okay, but tell whether the function is even, odd. Explain. Well, actually, the way to do this is f of negative x is equal to negative f of x. That's sort of the textbook definition. So if we say, what's f of 2? F of 2 is?
8.
8. And so what's f of negative 2?
Negative 8.
Negative 8. So f of negative 2 is the same as negative f of 2. So that's why, or negative 8. So f of negative x, which would be negative 2, is going to be the same as negative of that. And what it looks like in your calculator, it looks like this type of symmetry. And then also, what it says, describe the graph symmetry. And what you have is, the symmetry is like this. What kind of symmetry is that?
It's asymmetric.
It's actually symmetric. What this is, this has what we call 180-degree rotational symmetry. So 180-degree rotational symmetry, we'll call it.
I wasn't really into it earlier.
And so because we're going to be dismissed in another minute or so, we're not going to be able to do other problems than that today.
How long is this send-off?
Well, they say it was going to be at 2:30,
It'll be 20 minutes to go.
which is going to
It
be,
takes like 30 seconds.
yeah, well,
It's okay, we don't have to do more.
I really wanted to do more.
but we're going to do this.
Tired, so I don't think we should.
2 and 3 are going to be, we're going to start on tomorrow.
Perfect.
And we're going to be doing the translations according to the transformations, which we talked about earlier. We talked about it right here. So these types of transformations are what we're going to be talking about tomorrow. So just keep your powder dry on that, and we'll get going to that tomorrow, okay?
know how to stand.
Oh, yeah, thank you for reminding me.
Do something, you point it out yourself.
He teaches the students